In 1950, physicist Enrico Fermi was having lunch with colleagues when he posed a question that still haunts scientists today. Where is everybody? He wasn't asking about missing friends or lost keys. He was asking about alien civilizations, and the answer might be more terrifying than we ever imagined. It was July 1950. Los Alamos National Laboratory. Enrico Fermi, the Nobel Prize-winning physicist and one of the key scientists behind the Manhattan Project, was having lunch with Edward Teller and several other physicists. They were discussing the recent wave of UFO sightings that had captured public attention across the United States. As the conversation continued, Fermi quietly scribbled a few quick calculations on a napkin. Then he looked up and asked, "Where is everybody?" The question hung in the air like smoke. Think about it. Our Milky Way galaxy alone contains around 100 billion stars. Astronomers have confirmed more than 5,000 planets orbiting distant stars, and several dozen are considered potentially habitable. If even a tiny fraction of those worlds developed intelligent life, we might expect to see evidence of it by now. But we don't. The silence isn't just unsettling. It may be one of the greatest mysteries in the history of science. In 1961, astronomer Frank Drake stood at the world's largest radio telescope in Green Bank, West Virginia. He was about to introduce an idea that would change the search for extraterrestrial life forever. On a chalkboard, he wrote what would become the most famous equation in astrobiology: N equals R star times six F sub P times N sub Sorch times F sub L times F sub E times F sub C times L. 7 variables, 7 unknowns. Each one represents a step that a civilization must pass before it becomes detectable across the vast distances of space. R star. How many stars form each year? F sub P. What fraction of those stars have planets? N sub E. How many of those planets could support life? F sub L. On how many does life actually emerge? F sub I. How many evolve intelligent life? F sub C. How many develop technology capable of communicating across space? L. And for how long do those civilizations survive? The final variable may be the most important of all. If civilizations survive for millions of years, the galaxy should be filled with detectable signals. But if they destroy themselves shortly after developing advanced technology, they may disappear before anyone else ever knows they existed. Which raises a chilling possibility. Are we among the first civilizations in the galaxy, or one of the last? In 1998, economist Robin Hanson introduced an idea that would become one of the most unsettling explanations for the Fermi Paradox. He called it the Great Filter. The idea is deceptively simple. Somewhere between lifeless chemistry and a civilization capable of spreading across the stars lies an enormous barrier. Most life, if it ever begins at all, never makes it past this point. The real question is, where is the filter? If it's behind us, then humanity has already overcome the hardest obstacles. The emergence of complex, intelligent life may be extraordinarily rare, making us one of the few civilizations in the galaxy. But if the filter lies ahead, the future could be far more uncertain. Perhaps every advanced civilization eventually encounters a challenge it cannot survive: nuclear war, runaway climate change, an uncontrollable artificial intelligence, or a threat we haven't even discovered yet. No one knows whether the Great Filter is real. But if it is, every civilization that ever looked up at the stars may have faced the same question we do today. Will we become an interstellar civilization or another silent world? In 2000, paleontologist Peter Ward and astronomer Donald Brownlee proposed a controversial idea: They called it the rare Earth hypothesis. Their argument was simple, but profound. Complex life may require an extraordinarily rare combination of conditions. Earth orbits at just the right distance from a remarkably stable star. Our moon helps stabilize Earth's tilt, creating a relatively stable climate over millions of years. Jupiter may reduce the number of potentially catastrophic comet impacts. Earth's atmosphere contains the gases needed for complex organisms to thrive. Our magnetic field shields the planet from much of the Sun's harmful radiation. Even our location within the Milky Way may matter. Too close to the galactic center, and frequent supernovae could threaten life. Too far away, and there may be too few heavy elements to form rocky planets like Earth. Perhaps the universe is filled with simple life, microbes, primitive organisms, maybe even strange creatures swimming beneath the oceans of distant worlds. But intelligent civilizations capable of building telescopes, rockets, and radio signals may be extraordinarily rare. And if that's true, the silence of the universe becomes easier to understand. But what if the Great Filter is already behind us? What if the emergence of complex cells was so extraordinarily unlikely that it happened only once in Earth's 4 billion-year history? What if consciousness itself is one of evolution's rarest achievements? Neurons didn't evolve to solve equations or build telescopes. They evolved to help living creatures survive. Yet somewhere along the path of evolution, they became capable of curiosity, of imagination, of asking questions about the universe itself. Perhaps intelligence isn't the inevitable outcome of evolution. Perhaps it's the exception. And if that's true, we may be far rarer than we ever imagined. But what if the Great Filter is still ahead of us? What if every civilization eventually reaches a level of technological power, only to destroy itself before reaching the stars? History has shown that intelligence alone does not guarantee survival. Nuclear weapons, runaway climate change, global pandemics, artificial intelligence used in ways we cannot fully control, or technologies we haven't even imagined yet. In 1962, during the Cuban Missile Crisis, the world came frighteningly close to nuclear war. Today, humanity possesses technologies that are even more powerful, and in many ways, more unpredictable. Cyber attacks can disrupt critical infrastructure. Advances in biotechnology bring enormous promise, but also new risks. Artificial intelligence is transforming our world at unprecedented speed, raising difficult questions about safety, control, and responsibility. Perhaps every civilization eventually reaches a moment like this, a point where its greatest achievements become its greatest challenge. If that moment is the Great Filter. The future of humanity may depend on the choices we make today. In 1973, physicist John A. Ball proposed one of the most intriguing ideas in the search for extraterrestrial intelligence. What if intelligent alien civilizations already exist, but they have chosen not to contact us? Not because they fear us, and not because they're hostile, but because they're intentionally avoiding interference. Just as humans observe endangered animals in protected reserves without disturbing them, advanced civilizations might be observing Earth from a distance, watching, listening, waiting. Supporters of this idea imagine a kind of galactic prime directive, a rule against interfering with younger civilizations until they reach a certain level of scientific, technological, or social maturity. If such a rule exists, the silence we've experienced for decades wouldn't be evidence that we're alone. It would be evidence that we're being left to develop on our own. Of course, there is no scientific evidence that this is happening. The zoo hypothesis remains exactly that, a hypothesis. But it raises one final question. If someone were watching humanity from the stars, what would they see? So, where is everybody? The truth is, we still don't know. Perhaps intelligent life is extraordinarily rare. Perhaps civilizations destroy themselves before they reach the stars. Or perhaps advanced civilizations are out there, quietly observing, waiting for the right moment to make contact. Every explanation raises new questions, and every answer reminds us how little we truly know about the universe. Until we find undeniable evidence, the Fermi Paradox remains one of the greatest mysteries in science. And somewhere, beneath the same stars that inspired Enrico Fermi to ask a simple question, humanity is still searching for an answer.